covered until this moment how to use, how to calculate theta and y for beams using two methods. The first method, double integration method. The second method called conjugate beam method. Today we would like to learn how to calculate deflection for trusses. Actually, we don't have theta in truss because we don't have moment. The only thing in trusses is axial force. We have only deflection. So today I will start to cover a new topic which called virtual work method. Virtual work method. This method is very important if you are preparing for PE exam or FE exam, mostly for PE exam. You can expect a truss problem, and we would like to calculate deflection at a certain point. So virtual work is another method used mainly to calculate deflection for trusses. Actually, for your information, this method can be used for beams, also can be used for frames, also to calculate deflection, theta and y, for beams and the frames, like double integration and the conjugate beam. But in this course, in our course, we will focus to use virtual work method for trusses only. So we will expect truss looks like this with load, and we need to calculate deflection at a certain point. Before starting, I will use RISA. Just a second. So, are you still hearing me? Okay. I would like to start using RISA to solve the first problem in your note. We have a truss, looks like triangle. The angle is 5 inch times 5 inch times quarter, double angle. And we have one concentrated load, 150 pounds. So if you remember using RISA, guys, during your homework submission, please submit the results of your RISA. I'm not sure, I didn't see your homework submission yet, but most of you didn't do the RISA part. I'm not sure why. Do you know? So please, during your homework submission, please don't forget to put your results for RISA, because the homework asked to do RISA and hand calculation. Okay, starting from the current homework number 8, I think. Anyway, view drawing a grid. The first step, insert joint. I will create first node at 0, 0. Second node will be at 0 and 6. Third node will be at 8 and 6. Let's see what's going on. Insert members. Your cross section is hot rolled, and your cross section looks like a double angle. I will choose from here double angle, and my angle will be 5 times 5 times quarter. So go down until you hit 5 times 5 . Which one? Okay, we can use this one. Okay, 5 times 5. Okay, then I can start to draw my member. I forget something which is very important. Anybody can remind me what did I forget? I choose from here the cross section, hot rolled. So I will start to draw my member. Did I forget something? No, Burak. You have to submit solution like you did in homework number 5, I believe. Yeah, you have to get a copy or snipping tool and put your answer in a Word file. Okay, starting from the current homework, homework number 8, please do this. Anyway, anybody can tell me what should I do next before starting to draw my member? I forget something to draw members in Trusses. Anybody remind me? I think there is another option in this screen I need to highlight before starting. Any guide? Yes, thank you, Desmond. Yes. We have to check pinned at both ends. If you didn't check this option, you are drawing a beam or you are drawing a frame. Without this option, you are drawing another structure, not truss. Please don't forget, apply, go ahead and draw your members. We have roller here. We have roller, but this roller has horizontal reaction and there is no vertical reaction. So please insert boundaries. I will select roller, but the default roller in RISA give you reaction only in Y, but I need reaction in X. So I will create my roller with my hand. I need reaction in X and free in Y. Apply, go ahead and put your roller here. One more time, insert boundaries, and we have pin support at this location. We have concentrated load at this node. To insert joint load in Y direction, it will be negative, how much? 150. But your unit here is kept, so it will be 0.15. There you go. Before solving, we need to make load combination. For the first basic load case, we need to select load case 1, and the scale factor is 1. Then start to solve, and you can show up your results. We learned this in chapter 3, I'm sorry, in chapter 3, we can show up the axial force for this truss. We have member in tension, we have members in compression. But this is not our target today. I need to show you something looks like deflection. Let's start to show you deflection. I need to make magnification. Probably I will make it 1000 or okay, 5000 or okay, let's do it 10,000. Okay, can you watch the original shape of this truss and the new deformed shape of this truss due to the effect of 150 pounds? That makes sense for me because node number 3 will move down because your load direction is down. That makes sense. So how much is this deflection? If you open results, joint deflection, I can give you everything. But this value is very, very, very small, so you cannot watch anything here. Okay, let me try something different. I will insert joint load. This value will be too much. Let's try pink cap, negative. Very small. Okay, and solve. That makes sense because you are doing a magnification factor 10,000. Let's try 1,000 only. No, make it smaller. 100. Yeah, okay. So let's try to see results. Joint deflection. Here you go. We have values. For node number 1, this node moved down by negative means down 0.008 inch. Node number 2 did not move. That makes sense because node number 2 is a hinge. Node number 3, this node moved down because it's negative. How much? 0.061 inch. And moved horizontally also to right by 0.014 inch. In this method, virtual work method, we will learn how to calculate these values for truss. So we can get it by RISA, but we need to learn to understand how can we get these values by hand. And as you learn, if your value is negative, it will be opposite to the y direction. Your positive y is up, that means this point moved down. Your x displacement or deflection is positive, that means it is following the positive direction of x. That means this point moved to right. So the final answer for this joint moved down and to right. Any question so far for this point? Any question so far for this point for RISA? So please, during your homework 8, please, I need you to show me this picture and what is the value here. And you should draw deformed shape with your hand calculation and your values. So I need to make a comparison. Did you get the correct deformed shape? Did you get the correct answer or not? Okay. So your values from RISA must be very close to your values with hand calculation. This is the main target of this homework. Okay, just a second. So can you hear me right now? One more time. I'm sorry. I'm moving from my two Surface, from my laptop and my Surface Pro. Okay, so the target right now, we have a truss, and we need to figure out what is the vertical deflection at this point, but using hand calculation, using virtual work method. We have some steps, only 4 steps, just for fun. But I will remind you for something we learned in chapter 3. The first step to use this method, you need to solve your truss. You need to determine all internal forces on all members of your truss. First step. So we need to go back to chapter 3 to solve the internal forces in each member of the truss. And these forces, we will call it capital N. So first step is chapter 3. First step is chapter 3. Second step, go ahead and remove all the given load, all the external or all the given load on the truss. Remove them and put only 1 unit load. Put only 1 unit load. I'm sorry, I cannot get it. Okay, go ahead. If you have truss, looks like this: hinge, roller, and you have concentrated load given. 5 kip, 10 kip, 15 kip, all of these stuff in your problem. That makes sense. So the first step, I will solve this truss due to the given load. Chapter 3. Second step, I will remove all of these forces. I will remove 5, 10, 15, 10, 5, all of them. And I'm looking for what is the deflection, vertical deflection at this point. For example, I will put only 1 kip at this point. If you are looking for horizontal deflection, I will put at this point, for example, horizontal unit load, 1 kip. So the load, which is unit load, should be in the same direction as the specified deflection. If you are looking for horizontal deflection, I would like to calculate how much this point moved horizontally. I will put my unit load horizontally, to right or to left, as you like. If you would like to calculate vertical deflection, I need to calculate how much this point moved up or down. I will put vertical unit load up or down. Then I will solve this truss one more time and calculate the internal forces in each member, but due to the given unit load. This one or this one, based on what's required. The internal forces in each member at this moment, I will call it small n. Finally, your deflection or your final answer will be summation. Small n time capital N time L divide EA. And this solution will be set up in a table. Probably I didn't understand anything, but what I learned that I will solve my truss 2 times. The first time due to the given load and determine the internal forces in each member, which called capital N. Then I will remove all these forces and put only unit load, and I will solve my truss one more time due to unit load to get small n. Once I get capital N and the small n, I will use this equation to figure out the required deflection. Some notes, it's very important to tell me which member is in tension and which member is in compression, because if your member in compression, the value of the internal forces must be in negative. If the member in tension, you have to tell me because the force will be in positive. Let's start one example and see what's going on. This method is for fun, but if you are good in solving trusses in chapter 3, if you can, this method is for fun, just for fun. I have a question. Where do we put the new load? It's a good question. 1 kib you put in the center of the top? No. How do we know where to put it? Or it doesn't matter? No. Okay, let's try this example and you will see where and how can I put the unit load. This truss, we are looking to determine the vertical deflection at point B. I think this can answer your question, Burak. The problem asked you to determine the vertical deflection. That means your unit load must be vertical. 1 kib or 1 pound based on the unit. It's 1. Vertical, because I'm looking for vertical deflection. Your question is where at point B. That's it. So the problem will require something, and this deflection will guide you. How can I put the unit load? Is it vertical or horizontal? In our case, we are looking for vertical deflection. That means your unit load will be vertical. Where I'm looking for vertical deflection at B, then the vertical unit load will be at B. Anyway, anybody remember what was the first step? First step, we need to solve this truss due to the given load. So solve the truss due to given load. We have a vertical load 150. Go ahead and solve this truss. I think the first step, if you go back to chapter 3, we have a horizontal reaction here, probably XA. We have a horizontal reaction here, XC. We have vertical reaction here, YC. So if you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0 to figure out your reactions, I think YC will be 150. I think 150 times 8 divide 6. I think this reaction XA will be 200. I think the XC will be 200. So I need first to figure out reactions for this truss. Why? Why you need to figure out the reaction? Because I need to solve this truss. I will remind you how to solve it. Let's start with joint C. Joint C, we have horizontal reaction 200, we have vertical reaction 150, and what do you have else? I have a horizontal member called FCB. I have vertical member called FCA. We covered this stuff on chapter 3 for trusses. I will assume, but today we have more experience. So I will try to assume the correct direction from the beginning. I will assume this one in this direction. That makes sense because we have 200 to left. That means FCB will be to right. I will assume this force to down because I have 150 up, so FCA will be down. If you apply summation f of x equals 0, summation f of y equals 0 for this joint, I can figure out this force will be 200 and this force will be 150. It's very easy. Very easy. Piece of cake. And this force will be tension. And this force will be tension. Any questions so far? Any questions so far? Keep going. I just determined the forces in this member and this member only. I need to figure out the force in member AB. So let's try joint A. I'm sorry, no, it's joint B, joint B. Joint B, here you go. We have vertical force 150. And I have horizontal member and inclined member. I'm talking about joint B. This joint. I'm trying to solve this joint to figure out the force in this member. So I think the force in this member is known. How much? 200. Guys, forces in member CB from this side is tension, 200. That means from the other side will be 200. Tension. The force in this member from this side is tension. It will be from the other side, will be tension also, 150. I'm still looking for force in this member. Member AB. So I'm trying to solve this one. I will assume this force in this direction. That makes sense for me. FAB. Why that makes sense for you? Because we have 150 coming down. So I think the vertical component of this force must go up. If you assume this angle theta, and if you apply summation f of x equals 0 or summation f of y equals 0, I can figure out the value of force FAB. It will be, I think, it will be 250. Compression. Because this assumption is compression. So the force in this member will be compression, negative 250. This one is positive because it's tension. This one is positive because it's tension. If your force is tension, please put positive. If your force is negative, please put negative. What you did in this step, you just solved it. The truss means you determine all internal forces in all members. And these internal forces due to the given load. And these internal forces called capital N. Please go back to your steps. We are done with the first step. Go ahead and determine the internal forces, capital N, in each member. D2, the given load. Please don't forget, if your member in tension, your value will be positive. If your member in compression, your value will be in negative. And I am done. The internal forces in this member positive means tension, 200. The internal forces in this member positive, 150. The internal forces in this member negative, 250. And these internal forces called capital N. Any questions so far? Any questions so far? Second step. Second step. Second step, we need to remove all the external load. Any given load, please go ahead and remove it. Here is the truss. Yes. Here is the truss. Please remove any given load. So I will remove 150. And go ahead and put unit load. Where and how? Because I have two options. Probably I will put my unit load vertically or horizontally. And where? Okay, the problem will answer this question. We are looking for vertical deflection. Vertical means your unit load will be vertical. Where? We are looking for vertical deflection at point B, this point. So I will put my vertical unit load at point B. 1. Second step, please remove everything, any given load, and your internal forces that you calculated before. We have a truss with a new load. The new load will be unit load. How can I put it and where? Based on what is required in your problem. We are looking for vertical deflection. Your unit load will be vertical. At point B, the unit load will be at point B. Any questions so far, Brock? Did I answer your question? Okay. Then please go ahead and solve your truss one more time. Because we have a new truss with a new load. Go ahead and solve it one more time. So I'm so sorry. Go back to chapter 3 and start. If you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0 to figure out your reactions. So I think because you have new loads, that means we have new reaction. So I think we have reaction here. We have horizontal reaction here. We have vertical reaction. This reaction will be 1. And this horizontal reaction will be, I think, 8 divided 6. This one will be 1.33. This one will be 1.33. That is your reaction. This point is A, B, and C. So I will start with joint B for joint B. I'm sorry. This joint is C, not B. So I will start with joint C. What do you have at joint C? We have joint C, we have horizontal reaction here 1.33. We have vertical reaction here 1. And I have horizontal member called FCB and vertical member FCA. This one will be in tension and this one will be in tension directly without any calculation or calculator. This one will be 1.33 tension and this one will be 1 tension. So the internal forces in this member, this one will be in tension positive 1.33. This one will be in tension positive 1. I'm still looking for forces in member AB. So I will try to do joint equilibrium at joint B. So for joint B, what do you have at joint B? We have vertical force 1. We have horizontal force equal 1.33. We have inclined force called FAB. I'm going to assume this force like this. That makes sense because your vertical component will be opposite to the unit load. This force, I think it will be 1.67 compression. So the internal forces in this member will be compression, and the compression from this side also negative 1.67. Just to remind you, the third step, we need to solve the truss one more time due to the given, due to the unit load. These internal forces in your truss members will be called small n. Just a reminder. After you removed the given load and you put your unit load, please go ahead and solve your truss one more time and determine the internal forces, which called the small n in each member due to the unit load. Last step, we need to use this equation by setting up a table. So I will set up a table. This table will be first column member. How many members do you have? We have 3 in your problem. We have 3. Member A, B, member A, C, member C, B. Okay, go ahead and put these members. A, B, A, C, and C, B. What is the length of each member? What is the length of each member? I think member AB, the length for this member, the horizontal length is 8, the vertical length is 6, so the member AB will be 10 feet. So 10 feet in feet. Member AC, what is the length of member AC? 6 feet. What is the length of member CB? 8 feet. What? Sorry, guys. The next column, what is the value of capital N? What is the value of capital N? Okay, go back to your problem. The capital N value in this member AB, negative 250. Negative 250. Compression negative means. AC, the value for member AC, positive 150. Positive 150. For this member, negative, positive 200. Then, what is the value of small n in each member? What is the value of small n in each member? Okay, go back to your forces due to the unit load. This member, we have negative 1.67. We have negative 1.67. For the second member, we have positive 1. For the third member, we have positive 1.33. So guys, it's a very fun table. The first column, the name of each member. The second column, the length of each member. The third column, capital N, the internal forces you determine due to given load. The third or the last column, what is the internal forces in each member due to unit load. Then the final column will be small n time capital N time L. Just multiply this column by this column by this column. So 10 time 250, don't forget your sign, time 1.67, your value will be 4,175. 6 time 150 time 1, your value will be 900. 8 time 200 time 1.33, your value will be 2,128. Go ahead and get summation of the last column. Add this value plus this value plus this value. So your final answer will be 4175, will be 7,203. That means your deflection at B equal this value, 7,203 divide AE. I am done. Your final answer, your deflection equals summation. Small n time capital N time L. That you get, which is a summation. Summation, small n time capital N time L equal 7,203. This value divided by AE. Just to remind you, what is the meaning of AE? E, youngest modulus, which is the slope of the linear relationship between strain and stress. This line, E, youngest modulus, for concrete is different than for steel. A is the cross-section area. If you are talking about column or beam like this, A is the cross-section area, this area, or this area. These values will be given or constant, I don't care, like EI that you learned before, something like this. So your final deflection will be this summation divide EA. I can give you what is the vertical deflection at point B. So I think this method is very easy if you are familiar with how to solve trusses. First step, you need to solve your truss due to the given load. And these internal forces called capital N. Second step, you need to remove these loads and put one unit load. Where and how, based on what is required in this problem. We are looking for vertical deflection, so your unit load will be vertical. At B, this vertical load will be at B. Go ahead and solve the truss one more time due to the new load, which is unit load. So I'm done. The internal forces at this time will be called small n. Finally, please go ahead and set up a very simple table. The first column in this table, each member. The second one, what is the length of each member? What is the internal forces, capital N? What is the internal forces, small n? Go ahead and multiply these three columns together. Please don't forget your sign. But we have here negative time negative is positive. Positive time positive is positive. Positive time positive is positive. Sometimes you can find positive time negative, so be careful. Don't neglect your sign. Sometimes. Then go ahead and get the summation of this column, summation small n time capital N time L. This value, this summation divided by AE, cross-section area time Young's modulus, I can give you the final deflection at